Hello everyone, this is Dr. R. Subramanian Raja, Assistant Professor from Department of Physics, KPR Institute of Engineering and Technology, Coimbatore. I am here to share some of the insights about the conductor concept in physics and to solve a problem using MATLAB program. Our problem statement is to find the mobility of an electron in a conductor and to plot a graph between number of electrons versus mobility of electrons in a given conductor. Before going into this concept, let us have some basic understanding about the materials. Materials in general are broadly classified based on their conductivity or resistivity. There are two types of classification based on conductivity or resistivity. One is low resistivity or high conductivity conducting material, and other one is high resistivity or low conductivity conducting material. The first one is low resistivity or high conductivity material. They are commonly called as conducting materials. They are having high electrical and high thermal conductivity. So, because of this property, all kind of windings in electrical machines, apparatus and devices are involved with these materials. They are also used in the transmission of electrical lines. Some of the well-known examples are silver, copper, gold and aluminium. Copper and aluminium images are displayed for your references. Here comes the next, high resistivity or low conductivity material. They are commonly called as semiconductors and dielectrics. They have low electrical and low thermal conductivity. They are used as filaments for incandescent lamp because of these properties, and also as heating elements for electric heaters and electric ions. Some of the well-known examples are tungsten, carbon, nichrome, which is an alloy of nickel and chromium, manganese, which is an alloy of manganese and nickel. Here we are having a bulb image in which you will be able to see the tungsten filament which acts as the heating element there, and manganese wire are displayed for your references. Now we are moving into the conduction concept. It is a well-known fact that electrons are the major charge carriers in metals or in metallic conductor, which are responsible for conduction. But the question arises here is whether all the electrons are taking part in the conduction behavior. The answer is no, because we all know that electrons are distributed in the various orbitals of an atom. The outermost orbitals of an atom are called valence orbital, and the electrons in those valence orbital are called valence electrons. These valence electrons are freely moving here and there, so they can also be called as free electrons. These free electrons are responsible for conduction mechanism in the material, so they can be called as conduction electrons. So the electrons are moving freely like a molecule in a gas. We have to analyze the behavior of electron under two circumstances, one under the presence of electric field and one in the absence of electric field. So in the absence of electric field, if you are able to see the figure, you can find it out. The electrons are pointing out to the different direction, indicating that they are in random motion, making collision with each other. So during this collision, no energy will be lost. Whereas in the presence of electric field, electrons are gathered at one direction. For example, this is the metallic conductor which is connected to the power supply. So if you are applying the electric field in this direction, then electrons are gathered in the direction opposite to that of electric field, and current will be induced in the direction of electric field. So there are some basic terminologies associated with this conduction behavior. Some of the basic terminologies are drift velocity, mobility, mean free path, relaxation time, and finally conductivity. So drift velocity is defined as an average velocity acquired by the free electron in a particular direction. So how much velocity is acquired by the free electron in a particular direction defines your drift velocity. So which is represented by the symbol v to the base d, which is written as lambda by t meter per second. So the drift velocity acquired by the electrons for an unit electric field defines your mobility, that is mu, which can be written as Vd divided by E, which is expressed as meter square per volt per second. So the average distance traveled by the electron between two successive collisions gives your mean free path. As I said earlier, electrons are freely moving here and there, making collision with each other. So the distance traveled by the electron on an average between two successive collisions gives your mean free path. whereas the time taken by the electron to reach equilibrium position from disturbed position defines your relaxation time tau. We all know that electrons are making collision, so they are disturbed from their original position, and the time taken by the electron to recover from those disturbed position to reach equilibrium position defines your relaxation time. And finally, the conductivity, which is nothing but the quantity of electricity flowing per unit area per unit time. Conductivity can be written by the symbol sigma, which can be addressed as Ne square tau by m per ohm per meter. Now we are going to move towards our problem statement. Our problem statement is that we are having a uniform silver wire which is having a resistivity of 1.54 into 10 power minus 8 ohm per meter at room temperature. For an electric field along the wire of 1 volt per centimeter, we have to compute the mobility of an electron, assuming that there are 5.8 into 10 power 28 conduction electrons per meter cube. So the given parameters are n, which is number of free electrons, which is 5.8 in 10 power 28 conduction electrons per meter cube, and E is a constant, which is nothing but the charge of an electron, which is 1.6 into 10 power minus 19 coulomb, and rho is the electrical resistivity, which is given as 1.54 into 10 power minus 8 ohm per meter. We all know that there is a relation between the electrical conductivity sigma and mobility mu, which can be written as mu is equal to sigma by n into E, where n represents the number of electron and E represents the charge of an electron. But in our case, there is no conductivity value given, but instead of conductivity value, we are provided with the resistivity value of 1.54. So we have to establish another relation, that is conductivity sigma is inversely proportional to resistivity rho. So we are using this relation and substituting this relation in the above formula. So sigma is equal to 1 by rho. So we are getting mu is equal to 1 by rho into n into E. So we all know that rho value, n value, E value from the above statement, and after substituting all the known values, we are getting the mobility value as 6.9973 into 10 power minus 3 meter square per volt second. So this is the corresponding mobility value for the n free electrons, that is 5.8 into 10 power 28 conduction electrons per meter cube. This is the problem that I am going to be demonstrated using MATLAB. In MATLAB, for our understanding purposes, we are going to find the mobility. We have already find it here, but one of the aim is to plot a graph between number of free electrons and mobility. So whenever if we want to plot a graph, we need some sort of values. Here we are having only one n value, only one mobility value. But instead of having one n value, one mobility value, if we supply a range of n values, then it will be useful for us to plot a graph between various range of n and various mobilities that we are obtaining for those corresponding n values. Here comes the MATLAB coding for that problem. In the first statement, I am giving the problem statement, that is to find the mobility of electrons in silver. In the next two statements, I am introducing our variables, that is rho resistivity, sigma conductivity, n number of electrons, and E charge of an electron, mu is the mobility of an electron. These are all the variables that I am introducing here. In the below statement, I am specifying my variables with units, that is rho resistivity of silver wire, which is given as ohm meter, sigma conductivity of the silver wire, which is written as per ohm per meter, and n is the number of electrons in silver, which is expressed in meter cube, and E is the charge of an electron, which is expressed in coulomb, and mu represents the mobility of electrons. I am initializing the variable, that is I am assigning the value to that variable in the below statement, that is rho is given as 1.54 into 10 power minus 8. So 10 power minus 8 can be written as e power minus 8 here, and also as I said earlier, I am assigning the range of values to n. So it starts from 5.8 into 10 power 28 to 7.8 into 10 power 28 in the successive interval of 0.2. That means I am taking 5.8, 6, 6.2, 6.4, 6.6, 6.8, 7, 7.2, 7.4, 7.6, 7.8, totally 11 values. And as we all know that E is the charge of an electron, which is written as 1.602 into 10 power minus 19. The last statement, that is mu is equal to 1 by rho star n star E, gives your formula. So here multiplication can be represented by the symbol star. This is the MATLAB window, and this is the same set of coding that we have seen in the PPT. In addition to these codings, we have included some more codings because we want to plot a graph between number of electrons and mobility of electrons. The above coding is for a formulating purpose, that is to calculate the mobility for the range of n values, and these codings are helpful in creating the plot. So this coding contains the title, that is to create a plot between number of electrons versus mobility of electrons, and here x axis is labeled as number of electrons in meter cube, where y axis is labeled as mobility of electrons, which is expressed in meter square per volt per second, and the title of the graph is given as mobility of electrons in silver. So these are the codings that we are using to find the mobility of electrons in silver and to plot the graph between mobility of electrons and number of electrons in a given silver wire. So if we found the graph, you will be able to see that the mobility of electrons is found to be decreasing as the number of electrons is increasing. So this is the conclusion that we have arrived, and if you verify the value of mobility, which is found to be 6.9 for 5.8, which agrees well with this graphical value. So this is the mobility of electrons with respect to the n values, and these are all the various values of mobility of electrons for various n values given in x axis. Thank you.